right, so I'm completely unprepared for this video, but the funny thing is I actually did do this already, and what ended up happening was the camera where I was actually recording myself covered up all the work I was doing because I was doing the work over here. So uh, we're remaking this video. Okay, so we're going to learn how to use our borrowed bits, because remember, okay, let's say a class C network. Okay, it's going to have a subnet mask of, okay, let's kind of get farther down here on the screen. Okay, that's our subnet mask, okay, for our Class C network. Now, the first three octets, and you know, I really should do it like this. Really? I can't streak it. Oh, well, excuse the hell of me. All right, so let's actually go in here and just move these dots over. That way I can streak this out some more. Okay, there we go. Okay, whatever number you have. Now remember, this is, come on. And we're going to table this and insert left. This is our mask, okay? All right, and now we're going to, can I actually do one at the top? Let's find out. Yep, insert above, okay? All right, so, yeah, no, told you I was unprepared. Okay, so now, whatever we have set with all ones, okay, because our mass, remember, is going to be 255 because all our numbers set up as ones. If you add all those numbers, our 190, our 128, our 64, our 32, our 16, our 8, our 4, 2, and our 1. We add all those numbers up, they come up to 255, okay? That's why we cannot go higher than 255 in an actual octet or an actual number of the IP address. Now, if we had 9 bits, we could go up to 1024, okay? But we can't, right? All right, and I said 1024. I think that's right. Doesn't matter. Okay, so anyway, because you would take the 256 and times it by 2. No, I'm sorry. Not 1024. 2056. See, that's what happens when I start doing math in my head. All right, so now, give me a second. Whatever numbers are set to all ones, when our octet is set to all ones, whatever number that our mask is matching on, because every octet, like the first octet, is literally telling TCP/IP what to do with the first number in the octet of an IP address. And since they're all ones, that means that in order to communicate on the same network, okay, this number must be the same. Meaning that if I have an IP address of 193.168.0. whatever, I'm on a different network. It has to match. Okay? All right? So now, with our mask, okay, we have a possibility of 254 addresses. Okay? That means we have our number schemes set up in a way where I like to call it NFL ball. Okay? That will be our network number, our first valid IP address, our last valid IP address, and our broadcast address. Now, broadcast address is a way of communicating to all hosts, meaning whatever my broadcast address is, when I ping that particular address, that particular host, everyone's going to respond. It's going to go out to everybody. Okay? Now, this is a nice way to propagate your ARP table if you want to do it that way, or to find hosts on your network. Okay? Let's say you have the MAC address, but you don't know the IP address. Ping the broadcast address, look at your ARP table to find out what the MAC address is, and now you have the IP. Okay? That's the thing. Okay? Knowing what tools you have and the ability to use those tools to get the information that you need. Okay? Now, we're only going to focus when we're building out our subnetting. We're only going to focus on the particular octet that we are manipulating. Okay? In this scenario, okay, with our 255.255.255.0, okay, that has us having a mask of 255. Oh my God, are you serious? Okay. That leaves me with the fact that my first network is going to start off as 0, which always it is, when you're subnetting, okay? So I was going to start with 0, okay? And my next number is going to be 256//24 network, okay? Now, when I say /24, because I could write this as a /24, all that's doing is telling me that my mask is set with 24 bits on. The first 3 octets are all set to 1s. Okay? It's called a CIDR notation. CIDR. CIDR. Okay? Now, with our NFL ball, okay, whenever you're building this, okay, you're going to go via the increments of how many hosts we can do, okay? Now, our first number is 0, our second number is 256, okay, with a /24. Our broadcast address is always going to be one less number than your next number. Now, the 256 network doesn't exist, okay? All right? 255 is going to be one less than our next one, okay? Our last valid address is one less, and our first valid address is 1. Okay, so that means between our 192.168.0, okay, this is my network number. Okay, notice that 2 of the network numbers, which will be 192.168.0 are not part of our IP address as far as valid host. Okay, TCP/IP is not going to allow you to put the 0.0 on there or the 255 on there. Now with a Cisco device, you could actually put a command in there to actually remove that actual feature and allow us to use those two addresses. Okay. However, on the norm, TCP/IP is not going to allow you to do that. So let's go into here. Okay, the combination of IP address and subnet mask is invalid. Okay, same thing. All right, but we could put a 254 in there just fine. Okay, you see that? It took it. All right, now, but on a Cisco device, you can disable that feature. Like I said, everything in Cisco, 9 times out of 10, whatever rule you learn, it can be broken. All right, but nonetheless. So now, what we're going to do on the next, on our next lesson is how we're going to subnet this. Okay, because why we want to subnet this is because I don't need 254 addresses. All right, and when I come back, and hopefully be a little bit more oriented, all right, we're going to go through and understand why we're going to be needing subnetting. More tuned. Okay, so now, okay, why are we going to subnet? Well, you know, I don't need 254 addresses. Okay, I have a large company. Okay, I have tons of departments. My entire IP scheme, okay, all right, expands over the entire company across many locations. Okay, so maybe I'm using, okay, in the third octet, maybe I'm using many networks. Okay, maybe I'm using so many that actually I'm not even using the 168 anymore. I've gone up to 169, 170. Okay, because you got to understand, all right, if I'm doing a 192.168, okay, and my IP addresses for Class C is 192.168, okay, all right, actually, let's go look it up before I misspeak. All right. Class IP addresses ranges. Okay. All right. So 128 to 190. See, I was thinking about something different. Okay. So maybe I have been using this to the point where, let's go back. Okay. All right. That's not telling me the whole thing here. That's just the first octet. This is the chart that I want to see. All right, so, okay, so 192.168, okay, to 192, those are private IP addresses, sorry. 192, 0.0.0 to 223, okay. So you gotta understand that each one of these octets, okay, if I'm using a 168, which we haven't talked about private IP addresses yet, but that's what I'm using. I can actually go up to 255 in this octet. So maybe I started with a 192.168. Okay. Maybe I need to go to a 169. However, okay, you got to look at the concept that, first of all, I'm probably going to stay in the private IP addresses. All right. And the private IP address range, that means I have literally 255 networks alone, okay, that I can use as a private IP address range. Now, what is a private IP address? Private IP addresses, okay, versus a public IP address. A private IP address is an address that does not get routed via an ISP. Could it? Yeah. If they didn't actually put a block on that IP address to be routed. But by default, technically they should be denying that IP address to leave or to enter into their domain, right? So if I set up an IP address of a 192.168 address, which is a private IP address on my network, and send that traffic out to the internet, guess what? Internet should block it, okay? So we want to put private IP addresses on our internal networks, okay? We don't want to put public IP addresses, all right? My favorite IP address scheme is 200.200.200.x/24, okay, that I would use in my internal network. However, all right, that's dangerous if that information gets leaked out into the actual internet, okay? If I don't find a way of masking that IP address to another IP address that's on a public network, which the public network would be the internet, okay, I could have that public IP address being advertised out and having traffic come back to me for the real 200.200.200.x public IP address. And they will lose their traffic, okay? All their traffic would just stop. It would just stop, okay? Because I'm having traffic routed back to me. Does that make sense? All right, this will mess up the routing table of the internet, which is about 800,000 routes, by the way, just in case you're curious. All right, so we have private IP address ranges that we have decided for every class that we're going to use in order to not be routed via the internet. That's why every time you buy a router from Best Buy, it always has a 192.168.0.1.3.5. whatever. Okay, all right. That third ITAT is the number that we can keep changing. All right, as far as our network, because the range is, I'm sorry, this ITAT. Let's go back. No, these two ITATs, okay, are the ones that we can change. All right, so now notice how I have to keep going back. All right, it gets confusing because you got class A, class B, class C, and plus, guys, it's been years since I've actually taught this, so bear with me, and I apologize. But nonetheless, okay, so now the thing is, we don't need 254 for each address. Guess what we need? We need only 64. Okay, so now, by the powers of 2, we can determine how many networks we're using via this scheme. Okay, so let's go back to a IP address calculator. I should have left that there, but okay, number of usable hosts and total number of hosts. Okay, notice that the total number of hosts is 256. Every time I select this, that thing comes up. I apologize. Okay, all right, and the number of usable hosts, which are valid hosts, is always 2 less. 1 for the network, 1 for the broadcast. Okay, it tells you the subnet mask, tells you the wildcard, which is always the opposite of subnet mask. Okay, All right, it tells you the CIDR notation. Okay. All right. But it should tell me how many networks and how many hosts. I mean, how many networks I should be using. And I don't see that. Let's go to a different one. All right, let's try. Let's see what this comes up with. Okay, let's try. See, it's not telling me how many networks possible. Okay, let's go back. Let's do it this way. I think this gave me information that I needed here. In a Class C network, the first three architects are network portions. The Class C example has a major network address of 192.0.0. Octet 4, 8 bits for the local subnet can host. Perfect for networks less than 250. See, that's my point. You should be reading this. Don't forget. See how it does the subtraction of the bits, all that stuff, and it teaches all that. I'm not going to teach you that. Okay? All right? It's better to read. I know when to bow down. Okay. You know what? Am I missing something here? I think this is it. No, maybe not. Okay, so so this is the one that does it. Okay. So this is the chart that I'm looking for. All right. So let us look at this from, because we're looking for a 24-bit mask. Okay. So, all right. I want you to look at this and see how many networks are possible with slash 23. And let's find out if that's the case. All right, because we're going to take our calculator. That was a 23 mask. We're going to actually do 23, see if we come up with the same number. All right, so we're going to start off with 2. All right, so that's 2, right? There's 2 bits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All right, that's 24. So that doesn't even come out to be the same number. All right. So I'm still not finding the chart that I want to see, but that part's fine. What this is telling me is that with the 24 bits on, I'm going to have 16 million possible networks. Okay. All right. With our 8 bits on, all right, that's 2, 3, 4, 5, 6, 7, 8. That gives me a possibility of 256 hosts minus the 2. Okay, so now what I'm going to do is going from left to right, I'm going to borrow a bit. Okay, all right. Now when I borrow a bit, what I'm going to end up having is my subnet number is going to change, because remember, I'm turning on the 128th bit of that mask. So now my subnet is going to be 192.168.128. Now, in order to find out how many hosts I'm going to have within each network, okay, I'm going to take the magic number of 256 and minus whatever that mask number is, which is 128, which actually gives me 128. And then I'm going to write out those numbers starting with 0 in sequence. Okay, 0, 128, and then 256, because I'm going to add 128 to it. Okay, that is going to give, and then I'm going to fill in each one of these numbers for each network. All right, this is going to minus 1 from the number that is my next network number. I'm going to subtract 1. That's going to give me the broadcast of the previous network. Okay, 126. It's my last valid host, just minusing 1 and then adding 1, okay, from the network number itself that we're on. Okay, but that gives me 127 addresses, right? Technically 126. But at the same time, because we're not using the 0, remember, because it's a network number. So let me borrow another bit. Okay, and that's going to 128 plus 64 equals 192. Okay, I'm going to subtract that from my magic number of 256, right? And notice that the next number is going to be half of 128. What do you think if I added another bit? Okay, if I added another bit, that'll be 224. And 224 minus 256 is 32. Are you starting to realize that whatever number I have stopped at, as far as I'm making it a 1, that is going to be the number of hosts that is allowed? Do you see that relation? Okay, since this is the last one in my number, if I had a subnet mask of 224, I'm going to have 32 hosts. Okay, since I'm only doing a 192, that's going to give me 64 hosts. Okay, so that means now this number is going to change to 64, 128, 192. See how they just keep popping up? Okay, and then 256. Also, what you're going to realize is that every time I add another bit, the number of networks is going to double. Remember, with a 128, I only had 2 networks possible. Okay, here I have 4. 1, 2, 3, 4. Okay, and let's fill in our numbers here. Okay, now this is 127. Okay, this is 126. Okay, and this is going to be 65. Here, Since 64 is the next network, this is going to be a broadcast of 63. There's 62. Okay, and then 1. Next, 191, 190, 129. Okay, here, 255. That's why I always put the 256 in there. Because I'm telling you, that 255 always messes with me for some reason. Back in the day when I was learning it. All right, 254, 193. Okay, and now we have our 4 networks. So that's telling you that a 192.168.60 the 60 address slash, now we're using 2 bits now. So what is that? Okay. 3 times 8 is 24. 25, 26. This is a slash 26 cider. See how we did that? Okay. And now my subnet mask is going to be 255.255.255.192. Okay. Now, if that's the case, 192.168 dot, actually I did this wrong. 0. Now 66. Now look, 66 is over here on the 64th network. 60 is on the 0 network. TCP/IP is not going to allow that communication because you've already told TCP/IP what the boundaries is by setting the subnet mask. Does that make sense? Okay, so now, okay, we can go even farther. If I put it into a slash or I put another bit on here, that means now our networks are going to change to 8 networks. Okay, and just for giggles, let's do that. All right, first of all, let's take our calculator, all right, and say 192, 128 plus 64 plus 32, okay, 224. All right, that will give me a slash 27, okay, that will change my subnet mask to 224. And we already know, based on what I told you before, that we're going to have 32 hosts each. So that is going to make it like so. (32, 64, 96, 128. Notice how those numbers keep popping up, okay? So let's do 128 plus 32. That's 160, 192, 224, okay? So 160, 192, that number pops up again, 224, and then 256. Now, let's add in our numbers here. Let's do all the broadcasts first. 255, 223, 191, 159, 127, 95, 63, 31. Okay? Our last valid host is 30. 62, 94, 126, 158, 190, 222, 254. Oops. All right, and then our first valid host is 225, 193, 161, 129, 97, 65, 33. Okay, and now we're done. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we know 62 cannot talk to 66. Two different networks. Okay, now can we make this happen on different networks with our Cisco iOS? Yes, we can. Okay, matter of fact, you can do it with a PC too. But again, that's something we'll learn when we go more deeper into learning our little tricks on networking and stuff like that. Not in this video. Now, what you have done now is you have learned how to subnet a Class C network. You've also learned how to decide how many bits you need for how many hosts and networks. And if you missed that, we're going to cover it right now. Now, if I need 50 networks, okay? All right? If I need 50 networks per network as far as hosts, then I'm going to focus on the hosts themselves, right? By saying 2, 4, 8, 16, 32, 64, okay? 64 is going to give me, okay? 64 will give me the actual number of what? Think about it. That's going to give me my number to satisfy the 50 hosts that I need. Okay? Now, I drew out the numbers as far as bits. Okay? But that's not necessary. If I need 64 hosts, just write out my 128, 64, 32, 16, all the way down to 1, okay, and just put the damn bit on the 1 that's going to give me 64 hosts. Does that make sense? Okay? For some reason, nobody ever teaches it that way. Because they're not and you know what's funny? And it's nothing, this is not me ragging on anybody or anything else. It's just really, to be honest, they're not really seeing the relationships of the numbers. And that part is completely understandable because it took me a while before I even started realizing it. Okay? And I happen to realize it because I will always do my subnetting on paper at work. And I will always back it up with a calculator. And I'm going to tell you right now, 9 times out of 10, I will always make an error. Okay? I kid you not. We're just human beings. You know, the numbers that we see in our head, okay, our brain sees it on the paper, and that's not what we wrote down. We wrote down something else. All right? It's human nature. That's why I always use a calculator. I've been this way. I guess it's a sense of dyslexia or whatever you want to call it, but we all go through it. I go through it constantly. So I know better not to back up my math. But even today, I will write it out on paper to do my subnetting and then check it with a calculator. Okay? I will never want to lose this skill. All right? Now, this is the second time that I've actually recorded this video, and 9 times out of 10, which I'm not kidding, my second video is always worse than the first one. Okay? However, I can't teach you something if you couldn't see the screen because this whole screen was actually blocked out. Okay? And I was steadily talking as if you guys could see what I was talking about, and you couldn't see it because it was behind the actual video of me, and my face doesn't need to be on camera for something like this. Nonetheless, now, okay, so next will be Class B, not on this video, next one, but as always, guys, be strong, be determined, be Cisco. Oh, before we leave, Okay. Networks. If I wanted to have 15 networks, I would do the same thing, right? So that's when I would need the ones. Okay. 2, 4, 8, 16. Okay. In order for me to have 16 networks, I would at least have to have 4 bits, okay, going from left to right. Meaning that my first octet will at least have to have 4 bits that are on in order for me to have 16 networks. Okay, does that make sense? All right, so let's say if I had to have 40 networks. 2, 4, 8, 16, 32. I need to at least have 5 bits on, turned on in my subnet mask from left to right. Okay, that's how we do the host. That's how we do the networks. Okay, all right. So just keep in mind, we learned a lot in this video, not really 100% structured, but watch the video again. But I'm telling you, read it. Do not skip the reading part. Okay, and always remember, be strong, be determined,